Welcome to week 2, in which you're going to learn how to prove programs correct. So, to get things started, consider the following pseudocode. It's a very simple code, and the question you may want to ask yourself is, does this code correctly compute the sum of the elements of array B with size n? Week 1 equipped you with a number of useful tools. It taught you how to translate English sentences into predicates, and it also taught you how to prove. In this first exercise, you're going to use predicates to annotate this code so that you can convince yourself or someone else that it is actually correct. So what is an annotation? It's a comment about what's happening to the variables. It's a comment about the contents, or the state as we will say it, of the variables in the program. And it describes what is expected to be true about the state of the variables at the point where you insert the annotation. An assertion about the state of the variables is another more precise way of saying it. And it's best stated as a predicate so that there's no ambiguity and so that you can rigorously reason about the program. So let us illustrate that. Here is the same code segment, but now we've created some space where we can put some annotations. What kind of annotations might we want to add? Well, it's always good to start by saying what is in the variables when you get started. So here we say that n is the size of array B and it's non-negative. Upon completion, at the bottom here, S should equal the sum of the n elements of array B. Only when starting with an array of numbers of non-negative length can you hope for this program to compute the correct answer, which is that S equals the sum of the n elements of array B. About halfway into the program, just before the while loop, I inserted one more annotation. And there I say that S equals the sum of the first k elements of B. Obviously, as we are reasoning about a loop in which you compute that sum, that particular assertion is going to come up quite often. These are English sentences. What we want to do is translate those into predicates. So we say that 0 must be less than or equal to n before the program starts. Upon completion, S should be equal to the sum of the n elements of B. And before the while loop starts, we're saying here that S is equal to the sum of the first k elements of array B. And obviously k should be between 0 and n. Here we have the same annotated algorithm where we've taken the English away altogether. I want you to now do the homework, in which you will drag and drop assertions into this algorithm. And then when you're done with that, I want you to think about what those assertions say about the program. And then I'll see you in the next video where we will discuss the result.